For this lesson, we're going to be looking at both the sine law and cosine law together. And in particular, we're going to be talking about how do I choose between which of those I should use. So a quick reminder, for the sine law, we have a couple of ways that we write it. For the purpose of today's lesson, it doesn't really matter. Which of these methods you choose to write it in is really just a matter of convenience. It's just one of them is the reciprocal of the other. Same thing is true for the cosine law. It doesn't actually matter which of these you use because each one is just an algebraic manipulation of the other. What matters for both sine law and cosine law today is going to be what do I have available to work with, and then from that, what can I use, or how can I use that information to find an unknown. So it turns out that both the sine law and cosine law have limitations based on the information that you have available. So it turns out the sine law will only work if you have particular combinations of different sides and angles, and the cosine law, same limitations, different combinations of sides and angles. I'm going to start with a summary of those. So when do we decide to use which one? As you work with these more often and as you record these, so as you're doing your homework, you're actually making a note of which one of these you're using, you'll start to remember them and they'll start to come a little bit more naturally. But to start, you're probably going to want to refer to this page. So to use the sine law, we have two options when we want to use the sine law. And so we do it when we have side-side angle. And what does that look like? Side-side angle means that I have two sides adjacent to each other, and then I have the next angle after that side. And I want to distinguish that from this one, side angle side. So I'm actually going to start by looking at those two. So here's an example of side-side angle. I have a side, and then I continue to move along the outside of the triangle. So I have a side, and then I move along the outside of the triangle. I have another side, and then the next thing I encounter is the angle. So you can see I have a side, but I don't have this angle. So the next thing I find as I go around. So think about, that's the best way, is to imagine you're walking a path around the outside of the triangle or along the edge of the triangle. The first thing you find that you know is a side. And then we walk along the edge some more. The next thing I find that I know is another side. And the next thing I find that I know is an angle, side-side angle. And of course you can go the opposite direction. You can start here with your angle to a side to a side. That just makes an acronym. That's a dirty word, and we math teachers try to avoid such things. On the other hand, we can also start here with a side, and then we start walking around the edge of the triangle and we find an angle, and we continue to walk along the edge of the triangle and we find an angle. So that's another example. That's side angle angle. Now, how does this side-side angle differ from side angle side? Here I started with a side, and the very next thing I found was an angle. And then I continue from that angle, and then I find a side. So it has to do with the order that you find these things as you go around the outside of the triangle. So for these first two, side-side angle or side angle angle, and this one's sometimes known as angle angle side, and that's fine because that's not dirty. And those are the ones we'll use to the sine law to find our unknown. And here we have the cosine law, side angle side, and there's also the one option which is side side side. Now, using the sine law to find an unknown when I have one of these two, or using the cosine law when I have one of these two, it doesn't always mean you're going to be able to solve for the unknown that you are interested in. You might have to do a second step or even a third step. What I'm telling you is that if you have, for example, side-side angle, your only option here is to use the sine law, and that sine law is going to give you a particular value, and you're stuck with it. Now, from there, you might be able to use that new value to find yet another value, etc. But you can, given these three pieces of information, you will eventually be able to solve this entire triangle. Each step, you'll have to make a decision. Am I going to use sine law or cosine law? Am I going to use sine law or cosine law? Am I going to use something like the angle sum theorem? For example, here, I have two angles and a single side. Well, I can make a decision immediately to use the angle sum theorem to find the third angle. But when it comes to finding one of the other sides, I'm going to have to use the sine law. So let's take a look now at each of these cases individually. I want to illustrate to you why, for example, we're going to start with side-side angle. Why, with side-side angle, why am I constrained to the sine law? So let's take a look here. So I started at the number 6, and I start walking around the outside. There's no angle here, so, well, there's an angle, but it's not known. So a 6 I know. The next thing I know is this 11, and the next thing I know is this 50 degrees. So that's side-side angle. So what can we solve for? Now, I've tried to make these examples very easy, so I've labeled the triangles ABC. I've used the one form of the cosine law that refers to the angle A. So I've tried to make sure that the cosine law is relevant. This version, I don't even need to write a different version of the cosine law. So let's take a look at what do we know here. We know the angle A. So I could rewrite this as the sine of 50 degrees. Actually, before I do that, let me just show you another way that you could do this. So the angle A is 50 degrees, so I know that. I'm going to put a check mark next to the angle A. This 11 is across from the angle B. That's the side B. And this 6 is across from the angle A. So if we take a look at this, what can we solve for here? We actually can't solve for anything related to C, can we? The only thing that we can solve for here that's going to work out for us is going to be the angle B. Okay, so that's the, I'm going to label that instead with a 1. I'm going to say we have to solve for this first. And then, once we get the angle B, I could then use that to solve for the angle C second, because once I've got two angles, I can find a third angle. And then once I have this angle C, now I would be able to solve for the side length C third. So starting with the sine law to find the angle B, then I could move on and find the rest of the triangle. Let's take a look at the cosine law. So in the cosine law, I have the angle A, I have the side A, I have the side B. So here's the side B, and this is the side B. And so in theory, I guess if you really, really wanted to, you could use this, but that's pretty terrible, because what you'd end up with is you've got a quadratic equation to solve for the side length C. So I guess if you were a glutton for punishment, you could do this, but this is by far a less efficient way of doing this. You are so much better off using those first two ratios from the sine law. So it's not impossible to do this, but it's pretty ugly, and I certainly wouldn't recommend it, creating a quadratic equation to solve for this when you could just solve this very simple linear equation. So maybe I shouldn't say can, maybe I should say what should we be solving for here. Okay, what about angle, angle, side, which is the same as side, angle, angle? So here I've got a side and an angle and an angle. So with sine law, I have the side B, that's the 11. I've included the angle A, and I've included the angle B. And so pretty clearly from here, again, I can't do anything with C's yet. So the first thing I'm going to do is I could find the side A. And once I find the side A, I realize I still can't do anything for the side C. So this would be one of those examples where once I got to this point, I would probably have to, from here to go to anything over here, it looks like I'm going to have to make use of the cosine law. So I'm not going to get into detail about that now, but this is where these sorts of situations come up. So you need to be willing to use multiple strategies in order to solve this. Okay, so for side, angle, angle, you can see I'm going to start with the sine law, but then I would have to go to the cosine law for step 2. Let's just label that as step 2. And I don't know whether I don't know which of those I would use. Now, let's again label what we know. I tried to make it so the angle A was available. This version of the cosine law doesn't even have the angle B in it. I could write the version of the cosine law with the B in it. But if I do that one, it has the angle B in it, but it doesn't have the angle A in it. This one has the side B, which would be here, or the side B would be here. We don't know anything else. So in this case, I don't know the side A and I don't know the side C. I have two unknowns here, so this actually won't work. I don't know the side A, I don't know the side C, so I have two unknowns here. This one won't work. So in this case, it's actually what can we solve for? We must use the sine law here. Side, side, side. There's our third example. So what can we solve for here? So side, 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 that's pretty easy. Side, side, side. No matter which pair of ratios I choose, if I choose these first two, the angles A and B are unknown. I can't solve for two unknowns. If I choose the second two angles are unknowns. Or if I choose the first and the third, two angles are unknowns. So I cannot use the sine law in this case. On the other hand, I know the side A, I know the side B, I know the side C, and B and C. The only thing is A. So I could solve for the angle A, and in this case, to solve for the angle A, I would instead use the alternate form, b squared plus c squared minus a squared over 2bc. I know B, I know C, I know A, I know B, I know C. Everything on the right side is just a number. So from there, I should be able to solve for the angle A. So again, what can we solve for? Here we can solve for the angle A, and the only way to do it is with the cosine law. And last possible configuration, side, angle, side, side, angle, side. So what do we have? We have the side C, we have the angle A, and we have the side B. And this is very similar to the problem we ran into before, which is if I choose these first two, I'll have an unknown A and an unknown B. Unknown side A, unknown angle B. If I choose these second two, I have two unknown angles. And if I choose the first and the third, I have unknown side A, unknown angle C. So sine law cannot work here. If, on the other hand, I know the angle A, I know the side C and the side B. The side C, the side B, I'm going to be able to find the side length A using the cosine law. So, in this case, which law would you choose to solve the following triangles or the indicated angle? So in this case, I've got a side, an angle, that should say degrees, and a side. So this one is side angle side, side angle side, and so that means I'm going to use the cosine law. And so the question is, not only is it cosine law, but will cosine law actually give me what it is that I want? So I want this side length C. Well, I have the angle C, so yes, I'm going to use the form of the cosine law that says C squared equals A squared plus B squared, which are the other two sides I have, minus 2AB cosine of the angle C. I know the angle C, I know the other two sides, A and B, and I can solve for this side length C. For this one, I start my walk with this side, C, and I'm going to walk down towards this corner. Still no angle, so the next thing I run into is a side, and then I have an angle, side-side angle. This is side-side angle. And side-side angle tells us sine law. So using sine law, what is that going to get us? So let's write, this is again triangle ABC. We're looking for a side length, so I'm going to write it in this form. A over sine A equals B over sine B equals C over sine C. And we know the side A. Do we know the angle A? No, we don't know the angle A. We know the side B? No, but that's what we want to know. Do we know the angle B? No, we don't know the angle B. Do we know the side C? Yes. Do we know the angle C? Yes. So this is going to be one of those ones where I can't actually go directly to solving for the side B. What I'm going to have to do first is actually I'm going to have to solve for the angle A first. So I'm going to use this pair, this ratio, along with the side A to find the angle A. And then once I find the angle A, then I can find the angle B using the angle sum theorem. And then from the angle B, now I can use this ratio, either the sine law or cosine law, depending on what you have in your triangle. As more elements fill out in your triangle, you tend to have more options. You can now start to choose, am I going to use the sine law or cosine law? Because as you have more of these sides and more of these angles, you're actually able to meet the conditions side, 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 side angle, side, etc. much more easily. So the more you fill in the triangle, usually your first step is going to be pretty limited, but then things are going to open up and you're going to have more options on what to choose. Worst case, even if you forget all of these things, worst case is you go ahead and try the wrong thing and you'll end up with a situation like this. So let's say we had side angle side and you started with sine law and you start trying to fill things in. That's okay. Just be aware of the fact that if you run into a dead end, you need to backtrack a bit, and between sine law and cosine law, a dead end might mean you need to try the other version. So if you're trying sine and it doesn't work, then maybe switch to cosine. But as you can see, it's pretty easy to show, depending on the configuration, depending on what data you have available, it's pretty easy to show which one you should be using. Okay, and that's it for this lesson.